Yet. Wait.
Precious, what are you saying?
Nothing at all. Nothing yet.
Okay. Please, there should be no background noise. So please and please and please, everybody ensure that your mic is muted. Please and please, no background noise.
Oh, there you go. YouTube Live. There is a lag destiny, like 20 seconds or 25
Yeah,
seconds.
25 seconds.
Yeah,
Wow.
I think it's because of my internet, right? It's relative to somebody's internet, or it's the same for all laptops. What do you think? Because it's like 25 seconds or 30 seconds. Oh, there you go. It's like 20, about 10 seconds. 10 seconds.
That's much.
Yeah.
Yeah, is there any implication on the course or is there going to be any problem?
No, I don't think so. If I think during my presentations, I will look at the YouTube 1 or 2 times. So I think I can answer it live, or if I'm unconscious, but it's no problem.
All right. All right. Good. Well, so, can you see it live now?
Yes.
Can you see the YouTube live?
Yes,
Okay.
we are seeing the
All right.
YouTube now. 16 watching.
So, can you see it live now?
Yes.
Okay, Precious, please, you can start.
All right then. Good morning, good afternoon, or good evening to you all, depending on where you're joining us from. My name is Precious Okon, and I would be giving a brief introduction before the course starts today. Okay, so we have gone over the course outline and all of these things majorly. From here, you just need to know that the course will run from 3 p.m. to 5 p.m. and there are a lot of participants. It's a global thing. So it's definitely a lovely opportunity for anyone to be here. Okay, this this is the course outline. It involves it's definitely going to cover a lot of things, and everyone that participates um in this program will definitely learn so much. So ensure that you take advantage of every class and ensure you turn in your projects. Okay. So concerning the certification, the certificates will be available to those who complete the course. So if you're able to complete the course and go through all of the projects that will be given, hand them in on the Google Classroom in time, then you would be qualified for a certificate. To get a certificate, you would pay $5, and the payments would only be made after the classes. And the link for this payment will be released after completing the course. So um, the link wouldn't be out till next week, Saturday. So please endeavor to be patient concerning that. It will definitely come out, and then you can make your payments for the certificates. Before you could get a certificate, you need to score at least 30% in all 3 project assignments, have codes that are unique to yourself. Then you need to, the assignments will be submitted through Google Classroom. So, and you have to ensure that you submit them you're going to submit 2 documents. First of all, the PDF format of a PowerPoint presentation, which will contain a screenshot of your app and the formulas you intend using in your app, as well as your code in .py format. So endeavor to have these 2 things in place, and whenever you're handing in, ensure you upload the 2 documents. The deadline for submission is 12 a.m. before the next class. The course is being delivered through Zoom, but you all are watching through YouTube Live. So yes. Okay, these are the facilitators. The deadline for the assignments, the current one that was already given, project 1, has been extended to next week, Saturday, which is the 21st at 12 a.m. So, and make sure you work on your assignment by yourself. There's now like ample time for that. Endeavor to give it your best shot and upload your assignments before the due date and time. Yeah, so you submit that alongside the assignment for this week. Before we move on, I would just show a little tutorial on how to hand in your assignment, because there have been a lot of complaints concerning that. So I will just show that briefly using a sample. Okay, so assuming this is your class stream, this is the assignment place, you basically, okay, let me just take it from the stream so you can see the whole process. So say this is the assignment as shown on your Google Classroom. You tap on that block, and then you go to your work. Here it says your work. Under your work, you can, I'll just unsubmit this so you could see the process. Okay, so you can add something. You could select from either Google Drive, a link, or a file on your laptop, and then you turn it in. When you turn in your assignment, it should show handed in, and after that, you would be done submitting your assignment. So, yes. So thank you all so much for listening, and enjoyed the rest of the course. Today is day 3, and our instructor for today is Johannes Noir, who is a carbon geosequestration engineer, right, an OIO corporation, Japan Python developer for petroleum engineering and geoscience applications, and the founder of Python for Geoengineers community. It's definitely a pleasure to have him, and he's definitely going to teach so much, and you're definitely going to learn a lot from him. So just pay attention and enjoy today's class. Thank you so much for listening. Johannes, please.
Thanks, Precious, for your introduction and your tutorials for the assignments. One thing that I want to say that I and Destiny have looked into the assignments, and some of them are really, really amazing. So I hope that you submit the assignments because we are really thrilled to see yours. So first of all, hi everyone, welcome to our third session. First of all, I would like to say happy Diwali for you all. For those who are celebrating right now, it should be really, really joyful today and tomorrow. So yesterday or last week, we have already talked about how to do some basic things in Python. We have already done some calculations and made a calculator to calculate PVT properties. That's a nice start to learn Python. And today we want to go straight to real applications. We will talk directly about the real data sets and how we can apply Python to work on some workflows that we already know in the industry. So first of all, I would like to share my screen right now. Okay. Okay, all right. Today tutorial will go through some first introduction to Python because last week we haven't already covered about NumPy and Pandas and Matplotlib because of time limitation and several other things. So today I'd like to do that for you. And then we'll go straight to how to read well-log data using LASIO and doing, for example, triple combo and visualization. And then we'll go through interpretations to produce petrophysical variables like water saturation, porosity, and permeability. So have fun all. We'll go straight to the codes. But before we are talking about the codes, I think it's better for us to understand the basic theory of formation evaluation. Well, it started from how we understand what is well logs. As we understand, well logs are the records of the Earth. It's simply like we are seeing under the Earth. And the way we are seeing the rocks under the Earth is just by use like sonic log or gamma ray to see the shale volume, and also the neutron or the density log. We are seeing the matrix and the porosity. So well logs are the fundamental data that shapes the petroleum industry. And what is the objective of seeing the well logs? Well, first, it's for fun because we can see lots of measurements side by side, and we have to decide whether this formation has some hydrocarbon in the or volume, and also is this formation is porous, and can we make this formation as a reservoir that produces an economic amount of hydrocarbon? So it stems from the there are lots of methods that we are using. Some method we are usually using. For example, triple combo. It's seen my triple combo. Hi guys, I think I'm disconnected, just disconnected. So let me share my screen once again. Okay, so before we have been already talking about some basic information about well logs, and the another thing that we are using is also the neutron density. The neutron density plot is used to characterize the lithology of the matrix. For example, we are seeing sandstone, shale, carbonate, and dolomite. We are using this tool to plot all of the data, the NPHI and the rho B, to determine the matrix. And also, we are using Petrophysics to calculate some petrophysical variables here. There are some petrophysical variables that we know, such as water saturation, porosity, and V-shale. We are combining lots of logs. For example, sonic log. We are seeing the dense. We are seeing the type of the lithology, and also the water saturations. We are using resistivity log, and the shale volume. We are determining VSH from gamma ray, and the ones that you see here are the formulas that we are seeing generally in lots of reports and during our lesson formation evaluation when we are studying in the university. So these are the couples of equations. And we are going straight to the tool that we are going to use. So yesterday, last week, we have already done Python using IDEs, for example, Anaconda and PyCharm. Today, I'd like to introduce you to another tool that is called Google Colab. The difference in Google Colab and other IDEs is that we use Google Colab just like we are using cloud service. We are running the codes live using the internet, so we don't have to install any program in our laptop. And the second thing is GitHub. GitHub is a place where lots of people are developing programs like myself. I'm right now developing some programs like formation evaluation, Reservoir engineering repositories, and Reservoir simulations. Maybe some of you have been aware that I've been posting some of them. So we are today we want to use GitHub because GitHub stores lots of the data. We can store functions, we can store programs and data sets. So when we are using Python, we can get all of these things directly into the Google Colab. So I think it's better for us now to go to Google Colab on how we can do some Python in Google Colab. First of all, you can go through this link, colab.research.google.com. That is really similar to the notebook that Destiny had shown us last week. The difference is that it runs online, so it doesn't run on your local computer. So we just depend on the internet connection. And to make a new notebook, you just click the new notebook and you will be directed into a new notebook. Okay, so we are just waiting for a couple of seconds here. Okay, so in this notebook, you are seeing the pretty exactly notebook that we are working. First of all, we can maybe we want to make a new title for a new title. For example, intro to Python. Okay, Google Colab. So it's pretty simple. After we are connecting to the Google Colab, we don't have to install libraries, for example, NumPy, Pandas, and Matplotlib. All of these libraries, and I think not all just these three libraries like SciPy or lots of other libraries, TensorFlow, Keras, are already inside Google Colab. So the way we are starting our codes is by import NumPy SNP. The way I showed you last week, matplotlib.pyplot.splt and import pandas spd. Okay, because last week we haven't already discussed about how to use NumPy and these libraries, so I'd like to show you some basic codes first before we are going to formation evaluation. The first thing that I want to show you, for example, I want to make a trigonometric function, okay, and plot it using the matplotlib. we can make a comment like make a trigonometric array. But if you run, you can use control enter to run the cell. So it won't print result because this is a comment. Okay, so we can type np linspace to produce the array from 0 to k for 100 numbers. And if we print x, it will print the array. Okay, that's pretty simple. Okay, because we are, I want to transform x into sine and cosine function. We can first transform this x to a radian. Like you already know, right? To make a trigonometric function, we have to convert a number into radian, in radian units, not in degree units. X, and it will convert our x into radian units. And then we can do like this: np sine of x rad e2 for the cosine function. Okay, do the same. So it's already calculated. The trigonometric function has already calculated. And then we want to plot this function. Plot this function. We are using matplotlib to plot anything. So we can do plt.plot xrad y1 and plt.plot xrad y2. So it will print the sine function and the trigonometric function into only one plot. And if we plt.show, so this is the routine. When we are going to plot something, we are using PLT. It stands for the matplotlib pyplot as PLT. The way we are importing the libraries like this, and then we type the plt.show to show the plot. Okay. In some cases, like when we are working with PyCharm, if we don't do this plt.show, it won't print any result. And if we print plt.show, it will print us exactly the plot. Okay. And maybe we want to give a title: trigonometric function with size 20 and path 10. So path is the height of the title. Like if I give the path to 5, okay, so you recognize the difference, right? Okay, so we are using path equals 10, and then we are making the attributes of the plot, like x label, and this one is x, okay, and plt.y label, it's y, okay. All right, and the cool thing of the matplotlib is that we can use a lot of styles of plotting. Okay, you will see, like you will see after this. If I use this style that use, okay, you will recognize the difference. Okay, if you are writing like this, and then we are going back to our cell, you will see a more elegant look of your plot. So Seaborn and lots of other things in plt.style.use are the magic thing of Matplotlib. We can maybe also use other style, and it looks better. Like it depends on your preference, but I prefer to use Seaborn because it looks really great for visualization, and I want to restrict the X scale. So from min X, because we are plotting from 0 to 360. So the maximum value of the array, okay, the maximum value is 360 and the minimum value is 0. So I think we are waiting. Okay, so we don't have to use this. Okay, so what is the other thing that we can do right now? Okay, so we have already done with plotting. We are right now talking about the data frame. What is a data frame? Well, data frame is just like spreadsheet. If we are working with Excel, we know that spreadsheet is a table. Okay, so we can convert the results into a form of spreadsheet. And the way we are making a spreadsheet or a data frame in Python terminology, we use pandas. So I want to convert this the result into a data frame. The way I do this is by making, for example, I want to make a spreadsheet name Trigono, okay, or something else like trig, and I use this data frame, and here we want to assign the column names of the spreadsheet. So first, maybe X, okay, and this one is the value, the X value, and then sine X, Y1, and cos X, Y2. And if you print this data frame, you will see exactly, it looks like a spreadsheet, okay? But maybe we want to just show the first 10 rows of this spreadsheet. We can do like this, the head. Maybe we want to show the first 10 rows, we use head. And maybe if we want to produce the last 10 rows, we use tail. Okay, it's pretty simple, right? And so in data science or data analytics, we are making lots of data into data frames. So it's a routine for analyzing data. We are visualizing using matplotlib, and we are converting all of the arrays that we use from the field. For example, we are obtaining a production data. We are converting.
Johannes.
Yeah, Destiny.
Yeah. Sorry. Some persons are complaining that you are breaking. Do you think turning off your video will make it better, the network better, smoother?
So I turn off the video. Which one that I have to turn off?
Like your webcam.
Okay. Yeah. Sure. Okay. Is there any problem with the video?
They are thinking. We are thinking if you turn it off, because we are breaking. So we are thinking if you turn it off, the network will be smoother.
Okay. Yeah. Because I recognize that something lagging when I told before. Okay. Thanks, Destiny, for your suggestion. Okay. Is there any questions before we are continuing, Dest?
None yet. Just go on.
Okay. All right.
Okay. Then, sorry, sir. Sorry. He says you should explain the data frame range again.
Okay, we are right now starting the data frame discussion. So we are just starting. But here, if this data results into a table, so it's like we are making a spreadsheet in Excel, and we are so if, for example, you print the array, okay, like X array, you can see these numbers, right? It's not so comfortable to view. Okay, so if you want to make a nice detail or nice look of our data, we are using data frame. And we can use Pandas library. Okay. The other thing is to make a data frame. For example, I have like a list of names, Robbie and Alice, Rick and James, and I can think of other names like Ali. Okay, and then ages, like they have 20, 30, 21, 17, and 18. And these names has, maybe we can list how many cars that they have. Like Robbie don't have cars, doesn't have cars, and Alice has 2, Rick has 3, James has 1, and Ali is because Ali is a millionaire. She has 6 cars. Okay. Okay. So 5 names, 5 ages, 5 cars. And we want to transform all of these informations into a data frame or spreadsheet. So we are making quite the same like we did this before. For example, we want to make a list, okay, list or data. Panda data frame names, ages or ages, and cars. Okay, we print this data frame and we can see the table. All right. Maybe also we want to add a column to our data frame. For example, we want to produce a data of their hometown. Okay, so we can make a new array of their hometown. For example, Robbie is from Berlin, Alice is from Madras. Oops, okay. Rick is from London, James from Warsaw, and Ali from Paris. Okay, so we want to append the hometown columns into our data. So the way we are doing is to data. We create what column name that we want to produce, like hometown. Okay, and we define the array hometown. And if we print our data, the new column is just been appended to our data. And also in routines, we want to show, for example, I think we can add some more details here, like gender. Okay, I have to, okay, male, Robbie is male, Alice, female, Rick is male, James male, and Ali is female. Okay. And data. So I want to add a data to the data frame, and maybe we want to filter which one of these names are female and which one of these names are male. So I can view the proportion of the data that the names they are males. So we can see the details like the age, the cars, and the hometown. So we are doing like data. Okay, we can sort it. Data equals male. So it will sort out the data that has the gender of male. So we call this as mask in Python. So we are making a new mask male, and if we are doing data mask male, okay, it will print us the data that only the gender is only male. Okay, and if we want to sort the female one, we will produce the data that has the female gender. Okay, and also maybe we want to produce the second column. The second column is age. So the way we are doing is to data specify, for example, the age. Okay, we specify the age, and it will print only the column that is in the age column. Or also we can do like this, data.ilog. And this is more complicated because we have to know the indexing. And maybe I haven't already told that Python starts indexing from 0. So if we want to produce the first column, the name, okay, we are using like this. So it's 0, not 1, because Python starts indexing from 0. So if we want to print the second column, okay, so the way I declare it here, this character means that we want to print all of the row. If I want to make, I want to achieve the first like this, okay? So it reverse, like before we are printing the column, and right now we are printing the row. Okay, Alice. Okay. So that's it. This is, I think this is the introduction to NumPy, Matplotlib, and in Pandas. And I think this stuff, if you learn more, it is a really basic thing before we are going to the real application. So we will continue to our discussion here. We are going back to our presentation. So after this, we want to continue to the real application of the formation evaluation. Okay. So, okay, hey everyone. I think I'm disconnected. I'm disconnected twice. Okay, we are back right now. Destiny, do you hear me?
Yes, I can hear you. Go on, go on.
Oh yeah, sure. Okay, that's good. Okay, we are continuing to formation evaluation right now. Okay, so we are going back to our use formation evaluation library to do formation evaluation application in Python. So formation evaluation is basically my repository. I stored it in my GitHub. It can handle some jobs like producing ND-plot, Neutron density, and log visualization. If you want to see the GitHub, you can go to this link, formation evaluation. and you will see the data and all of the functions that we will use. Okay, so yeah, so yeah, this is the formation evaluation GitHub.
Sorry, Johannes.
This is the
Johannes.
data that we want to use. Hi, Destiny.
Yeah. Sorry, can you come again how you got here? At that point you broke off. You were breaking. So okay.
Okay. Yeah, right now we are continuing to formation evaluation. And if you go to this link, I guess you have already seen this link, right? And if you go to this link, you will see the data that we are going to use today. This is the data. So if we are going to this data, the last data, it is the Wellog data that we will use today. And you can see the last file inside. Okay, I think that looks good. I can see that. Okay, so these are the logs that we want to use, and also we also have um, the top name or the formation tops. So this data lists down all the formation names of this Wellog. Okay. I think we can. Okay, so this one is the formation names. So this is the data that we want to use. And if you are seeing here are the function that we want to use. This function, the ND plot, label generator, triple combo, and Wellog display. Okay, so I think it's better to start the formation evaluation right now. You can go to this link, bit.ly Python FE. Okay, so if you are already seeing my screen right now, you can go inside the link bit.ly Python FE. In this notebook, we will work on the codes. So if we are going inside this link, okay, you will see a new notebook that coming up to you. So this is our notebook, okay? So in this notebook, we are going to code, okay? First of all, we can click File and save a copy in Drive to make it our own notebook, okay? And if you are seeing already a new window that is coming, so it is our notebook. So we can start our codes in this notebook. Okay, so first of all, the way we are doing like before is to import all of the libraries that we are that we want. NumPy, Math, Pandas. So we are waiting for a second to connect our notebook. And because we want to download the last file and we want to work on it, we use a library that is called Lazio. So first we have to install the library because this library hasn't already installed in Google Colab. And we can manually install this library by typing this code, and then we import this library. Okay. So it has been already installed right now. And the next cell you see here, this is the GitHub. because I have already explained before that we will use the data and some functions from this repository. So first of all, we want to clone this repository to our own. So we get all of the functions and the data inside our notebook, okay, just at once. And we import the system, and from the system, I want to import all of the contents of this repository. If you run this cell, it will collect all the functions and all the data. Okay, and if you are seeing in this panel, you will see the formation evaluation repository, and this is the data. Okay, and these are the functions that we will use for today. And then from this repository, I want to import these four functions. First one is the label generator, triple combo, Veloc display, and ntplot. So the way we are importing is by typing all of the libraries. Okay, and then triple combo, import triple combo from ntplot, import ntplot, and from Veloc display, import Veloc display. The way we are working like this is like we are importing these three libraries. So from all of these files, I want to import all of these functions. And then here you can see one function that we will use for this training. So basically, this function is for calculating the permeability for several formations. The data that we will use right now is the data from the fall field, and fall field data is an open data set from Equinor company. You can go to the website and you can see the databases. There are lots of data there. One of them is Veloc, and right now we will calculate several petrophysical variables for several formations in the fall field. So basically, there are lots of formations in the field. Three formations that is quite important is Hugin formation, Heather, and Sleipner. And if you have been already knowing about fall field, Hugin reservoir is the producing reservoir, the producing reservoir, and above this reservoir there is a formation named Heather, and below this reservoir there is a formation named Sleipner. And today we will do formation evaluation for these three formations.
Johannes,
Yeah,
you've
sure,
got
definitely.
a question here. So
yes,
what is
sure.
LASIO used for?
Okay, LASIO is a library for processing Veloc data. So we can use LASIO for reading last data, and then we can also write last data. I believe that you have already know about what is last data. Veloc data is in the format of LAS. So if we want to open the Velocs, we can use LASIO. Well, there are also lots of libraries to open LAS. For example, Wally is also a library to use to read Veloc data. And for now, we are using LASIO to do the job. And okay, so right here, the file path. So this is the path to our directory. So if you are seeing this in this directory, you can see the data. Okay, this one is the data. Okay, and this file path describes the path of the data. And then we will read the last data. Sorry, lastio.read file path. So this code will read the well logs using Lasio library. Okay. Okay, so I forgot to assign it into a new variable, for example, well. Okay, so it has been already successful for reading the log data. And then, as usual, we may want to check what is inside our log data, what measurements like sonic log or gamma ray or anything else that is available in our data. Actually, we can see it manually inside our computer. We can use Notepad. Okay, that's pretty simple. If we want to do a more elegant way of using Python, you can do checking the file using this code, and it will print all of the measurements in our well data. Sorry, it's not Lasio, but well, because we are assigning into a new variable well. Okay, so I want to check all the keys in my variable that is called well. So you can see here all of the measurements like the caliper, density correction, the compressional DT log, and the elastic log, gamma ray, and PHI, and all the logs are that is available in this data. And also, we may want to check. This is pretty important to check the units of all of these logs. We can use this well.curves to check the units of each measurement. Okay, you are seeing here the depths. The depth are in meter and caliper, density correction, and the DT, the travel time log, and the gamma ray, and all the logs. Okay, and the resistivity, and maybe the ROP, and all of the logs that is contained in this data. It is quite important for you to check, first of all, what units are we working with this data. Okay, so you can use dot curves to identify all of the units in our data. And this is the most important thing. We want to see inside the data. Okay, the way we want to see inside the data, inside the well, is by using this. Okay, so if you are seeing in this screen, what do you have anything to say from this data? Well, I don't think that there is a quite there's a quite nice look of this data, because I prefer to look this data into a kind of spreadsheet or the data frame that we have already described before. This is the look of array and not into a data frame. So we can convert this look or the appearance of this data. We can convert this data into a data frame. So we are using well.df. df is a data frame. Okay, and then we can see that our data right now has been in the form. Sorry, So every time that we are doing this code, I forgot to add this line. So this is a bit complicated when we are in this stage, because we have to add this reset index to move this depth to a column. Okay, so we have to repeat this once again because we just forgot to add the reset index to. And then if we are going back to this code, we are running this code with this additional. And if we right now print the code, we print the data frame, we can see the difference. Right now, the def is already in the column. Okay. And this one is the index of this data frame. Why I'm making this kind of form? Because when we are analyzing a data frame, we have to care about the shape of our data frame. We have to ensure that the depth are in the columns, not in this index column. So every time we convert the data into a data frame, we pass this reset index to move the depth to this columns. Okay, so we are moving on right now. Um, we have also the file that defines all the formation names. This is the file. Okay, so basically you can see the file here. If we are going to this we open this one, you can see inside the file here. Okay, so these are the formation that we will work. So there is Heather, Hugin, and Sleipner formation. The last three formations that we will use for this. This is the file path for our file, and we want to read this
Johannes,
file. Yes, Destiny.
some persons are like you should you are moving a bit too fast. I don't know if you could
Sure.
slow the pace a bit.
Do you need to repeat on any part?
And no, just go on, but just the pace, just be a little bit slower than you.
Sure. Okay. So maybe if you are missing what things that we have covered, okay. So maybe I can review what we have already done before. Okay. So first of all, we are reading the log data. We are using Lasio to read the well log data. And if we pass this key, this is for viewing all the measurements that we have inside the data. And if we pass this key that curves, okay, you can see all of the details, including the units that is in the data. Okay, actually, we don't have to do this in our workflow. This is only to check or to know first before we are working with the data. It's just natural if we are seeing the last data into a notepad. So if we are working with Python, we can do this code to identify what units or what measurements that we have. And why am I doing like this? I want to convert the data from this form or this shape because I bet that you don't like this kind of appearance of data, okay? All right. So we can convert any data into a data frame, and we are using Pandas, that is a library for data processing, to convert the data that looks maybe weird or not usual for us to see in the Excel or spreadsheet into a kind of form that we can see the data frame or the spreadsheet. And right now, we are continuing to the formation, how to assess the formation labels. If you are seeing here, this data, it doesn't have the label or the formation label. Okay. And the key thing that I want to show to you, I want to convert this data so that this data has formation label names. So for each of these recorded depth, they have their respective formation names. And we have already the formation file. If you are going to this link, you can see the data. Maybe I can show you the data here, okay, to make it clear. So for formation evaluation, we can see in this GitHub. So you can freely fork if you find this, and I will continually can bring another look into the data. And the data, the formation label is inside this file. Okay, you can see here. This is the file that we will use. This is the formation names. In this tutorial, we will only use this three formation names: the header, Hugin, which is the reservoir that is producing hydrocarbon in full field, and the Sleipner formation. And we will go back to our notebook here. We have already had our file, and then we can read. The way we are reading the file is just similar to the way we did Panda to read the file. So maybe we can assign a new variable like tops pd. We are using read underscore CSV to receive all of the data. Okay. And if we print the data, you can see the formation labels and the depths. Okay. And as I have already shared to you before, we can see the first 5 rows of this data by using head 5 to see the first 5 rows of the data. Okay, and if we want to see the tail, we can use this tail to view the last 5 rows of the data. So we are right now moving on to in this to do several things. The first one, we want to visualize all of these well logs. The second one, we want to make the triple combo to identify which range that has a considerable amount of hydrocarbon. Because if you have already known about petrophysics or formation evaluation, I believe that you have already known how to read a triple combo. If there is a hydrocarbon, it means sorry, if there is a crossover between RHOB and NPHI, it can mean, or it can possibly mean, there is a hydrocarbon inside the formation. But in some cases, it doesn't tell the way we are interpreting the well log. And the third thing, I want to show how to produce the neutron and density log. And the fourth thing, I want to compute the petrophysical variables from our well log data. And now we are moving on. First, we want to visualize these logs in our data. And the function to do this job, we are using what is called as the well log display function. You can see all of the functions here. So the ND plot is a function to produce the neutron density. This is for to view the triple combo, and the right now we want to generate from this file. I want to generate the formation names for all of these logs. Okay, so for example, we are seeing here in the tops. For example, Sleipner formation, it starts from 3,700 meter. So in this last rows of the well log data, because you guess, because these depths are in the Sleipner formation, I want to assign all of these depths, all of the formation names. So we are using this function. I think it's easier to see that we want to use for this job is the label generator. Okay. And the first thing, before you are using any function, you have to know what inputs are required for a certain function. And the way we want to produce or to find out the inputs that is required for our function is by typing help for our functions. So you can see here all of the details of these functions. These are the inputs for our function. Okay, so the first input is df well, df tops, column def, and label name. These are the inputs. So I think I have to explain step by step on how to use a function, because we haven't already touched on how to use a function to work on Python. So first of all, if you are seeing here, you can copy and paste this input. Okay, and then for all of these inputs, you type down the data that we have already produced before. Okay, so df well is the data that we have already produced when we are producing this well log data. So df well corresponds to our well log data, and df tops are the data frame that describes all of these information labels. So we type it at tops, column defs in our original data frame. Okay, so because this data has a column name, this one, okay, maybe we can copy and we paste here. So column def describes the column name of the def column in our original data frame, and label name is the name of column that we want to produce. So in this case, if we are going back to this data frame, to this data, okay, you haven't seen any formation column, right? And we want to make our own name to this column. I want to make it like the label name is formation label. Maybe you want something, another name, for example, formation name. It's up to you. So it is only the name that you want to produce. But for now, I want to use this name. And right now, we are now executing the function to generate the labels. So we can use this label generator, and it uses help. Okay, so we can maybe copy this line and then paste it here. So I think this is my advice to beginners in Python. If you have already confident in how to use Python, you don't have to copy and paste the information in the help section because so first of all, you have to know what the functions is for, and then all of the inputs that you have to use. And then after you have already understand this function, you can build your own code. So if we are executing this function, and we can see that this data has already had this formation name. Okay. Okay. So you recognize it, right? We have already see our new column name compared to our previous data frame. Here we don't have the formation label. Okay. And one thing that you spot, maybe if you are you are seeing here, you will spot that this rows has a formation label as a non-numerical one. So it means that it is unidentified or unknown formation. And in data processing, it is quite routine that we have to transform this non-value to a certain string or a certain number, okay? Because it will impact on how we process the data. If we are handling large data, we have to spot which rows has a certain has a non-numerical values or doesn't have any values. And in those rows, you have to be able to give a string, or you have to transform these rows so that they have a meaning for our data. Or we can also delete this data. But in this data, I don't want to delete any part of the data that has non-numerical values. So I want to change this formation label that has a non-numerical values to a, so I want to call this formation unidentified as unknown. So we can replace all the rows in this column name formation labels to unknown. Okay, so the way we are doing is by typing this code. Well, formation.label. We are using I think is so replace all nuns. Okay. Okay. Well, for unknown, I think where formation label replace non-information label column. So we can use this, okay, label, okay. Maybe I quite lost here. Well, okay. False. Okay, maybe I have to create a mask or something. Well formation label, well formation label. So I have to convert all of this non-numerical values to unknown value, and it print false here. So it replace none value. Well formation label replace none. String is null. Well formation label k okay is null. It's unknown. False. All right, maybe I can make a mask here. Mask unknown. Well, formation label. Hmm. Is null. Okay, I think we can delete this part of the data that has a certain anomalies here. Okay, so this one is our okay. So I have to go through. Okay, I think I've just been disconnected here. Okay, so wait a minute. I think I just got lost in connection. Okay.
You're back now, right? Yeah, I can hear you. You're back, right?
Yeah. I have to I have to share my screen again, but because the connection is not so good, I have to wait for a couple of minutes. So wait a second.
Okay.
Okay.
It's all right.
Okay.
Go on.
So do we have any other questions so far, Des?
Yeah. One says, what's FM.tops used for? Larissa Troy says, what's the reset.index? What
Okay.
index? What? Why reset index? And then, yeah, that's just it.
Okay. So, okay, I have to maybe I have to share my screen so that it will be clear. Okay. Wait a minute. Okay, share my screen. Yeah, exactly. Okay, so wait a minute. I think I have to go through this again. So, okay. Okay, so the question is, why do we have to reset? Yeah, we explained before that when we are importing our well log using LASIO, so maybe we can repeat it because it has been already changed right there in below. If we print the the well-log data without using. So I want to compare without using reset index and using reset index. So first of all, we want to data frame because it has still this shape. So if we print the well data, okay, into a data frame, you can see here the depth is not in line with this column. Okay, so do you get what I mean? It's like it is not in line. It is lower than this column. What it means? It means that before, when we are showing you the data, so maybe I can go back to my previous notebook here about the introduction to NumPy. Okay, so first, for example, here's this data. All of these columns are in line with each other. Okay, so if we have already found this column in line, we can this. I want to print all of the columns in name, so it's not well but data because it's a different section. So it will print all of the information in this data frame. Okay, but if we are seeing here, all of the information inside this column, it won't print as any result because it's not a column. Okay, I think we cannot see well depth. Maybe I can well DT. Oh, it seems that okay, it's quite weird because yesterday I just encountered that with this kind of condition we cannot print the depth. Okay, so it seems that we can also use this column. All right, I think okay. I think without using reset.index, it can print anything fine. Lots of when we are operating with the data, and the way we are seeing here like this, it is not a normal data that we are looking in our daily routine, because this depth is actually not a column. It is corresponding to index. Okay, so maybe if you are knowing on how to operating in spreadsheet or in Excel, you will find that the leftmost column is 0, 1, 2, 3, 4, 5, 6. Okay, but here it should be in this kind of form. Like we can print the first row, the second row, if we are showing the data into this kind of form. You get what I mean? Like it is this kind of form, index 0 to, it's like spreadsheet, but in this kind of form, it is not quite looks like a spreadsheet. So that's why I'm converting this data frame using reset index. So it will change our data. This will appear as the index of our data. Okay. So we are going back to our previous discussion. Okay, so I think I have to print this again. Okay. 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 So first, we have been already in this step before. Okay, and we have been generating it before to generate the labels. And we print the well. It has the non-numerical values here, right? Okay, and here, before I have been coded on non-values to an unknown names. So if we print this code, we print again the frame. All of these non-values have been already transformed into unknown labels. Okay, so it's quite tricky, but it's quite important before you are handling with large data. Okay, right now we want to visualize this data into a well logs. Okay, we are using this function well log display to display all of the logs of this data. So like the way we are already using before, we use well log display. So we want to see what inputs are required to execute these functions. So help well log display, we will see the descriptions of our functions as well as the inputs that we can use for this function. So you can see all of the inputs here. And one thing I want to say that in a function, there is that we call as obligatory input and optional inputs that we have inputs. If we to input these variables, it's okay, it's fine, because these optional inputs are to maybe we want to make something better, something looks better, or I want to modify it a little bit. So optional variables are just working that way. And if you are seeing here, all of the variables that has equals this, okay, equals are this ones are the optional variables. And this one, the df, okay, the df is this one is the obligatory input, the ones that we have to input anytime. So next, we are using this function to generate the well log display. So we can copy and paste. This is for beginner. So we can variables. Okay. One by one, we define these variables. So df is the data frame that we have already working before, is the well, right? So well is our data frame. Okay. Well is our data frame. So we define df as the data frame. Column depth are the name of the column that has depth information. And the name of the column is depth. So we input depth here. The column list is all the logs that we want to produce. So for example, I want to produce resistivity log, density log, sonic log. We define all of these logs in this list. And here I want to produce this logs, okay? So I want to produce the neutron density, gamma ray resistivity, photoelectric, caliper, the compressional dt, and the elastic dt. And now we are passing the function. We use the function Welloc display. And then we pass all the inputs in our function. Okay. And you will see the result. Column in, okay. It's not column input. So you will see here the Welloc display of our Welloc, okay? So these ones are the logs, are all the logs that we are recognized. So we recognize here. So you can see all the logs, okay, corresponds to this logs that we want to display. But one thing, maybe we want to make this visualization looks better. So at this stage, we can use these optional variables to be added to our function. So, here, maybe I want to make this Welloc display from certain depth to another depth. So maybe I want to produce the Welloc from 2,800 to 3,400. And I want to impose different colors for each log. And I want to adjust this scale so that it looks better. And one thing that is quite uncomfortable to see is this resistivity log. Petrophysicists really doesn't like this kind of visualization because into a semi log. And we can do this, okay? We can do this by using all of these optional variables. Okay, so right now I want to make this visualization looks better. So we still use our inputs, our previous inputs, but we add some new other inputs. So we can copy and this inputs. Sorry. Okay, so okay, this one is the optional variables, and we copy and paste here. Okay, copy and paste. And for each of these variables, we define our preferred visualization and attributes maybe. So this one is all of our optional inputs. So in this first variable corresponds to the resistivity column, because I have told earlier that petrophysicists doesn't want to look this representation. They prefer to convert this into semi-log plot. So we can define this plot into a semi-log plot. And the way we do this is by typing what column is the resistivity, because resistivity is in the fourth column. So we define it as 3. Why 3? I have told before that Python starts indexing from 0. So 4 corresponds to 3. Okay. So this is the column for the resistivity, and min depth and max depth are the depth range that I want to produce. For example, I want to produce from this to this depth. Okay. And this way, the column min and column max, okay, are all the axes. So maybe you want to adjust this axis. For example, for maybe I can change this appearance to white so it looks better. Okay, so you can see here the NPHI, the rho B. We have maybe okay this gamma ray. I want to make the x-axis from 0 to 200. So I want to adjust the scales for this, and for this. This is the caliper from 8.5 to 9, and restrict this to only 200. We can define our minimum and maximum range of our column by typing. So maybe we can copy and paste here. Okay, so we know one of this value. Okay, so for NPHI, I want to produce the minimum scale from 0. Okay, HOB, okay, 1.95 for gamma ray 0, for resistivity 0.01, PEF. Maybe I want to go back here, PEF, I want some information from 5, caliper from 8.5, 8.5, DT from, so I want to show from 60, maybe 60. And for elastic lock, I want to show from 100. Okay, these are the minimum values, and these are the maximum values for NPHI, because it's quite a routine to produce it until 0.45, because it's the maximum for any rocks will have, until 100 resistivity, until 200, maybe PEF until 9, caliper, sorry, PF until PF here until 12.5, caliper until 9, gamma DT until okay, this one, and 300. And then we can make all of these locks the colors we want. So for example, for NPHI, I want something, the color as black, for RHOB, blue, gamma ray, red, RT, orange, EF. Oh, what colors that I can think of? Gray, caliper, green, DT. I think we have already run out of colors. Okay, so violet, and the last one is this cyan. Okay. Okay. So if you want to, so actually these 4 variables are not so important. So if you want to produce all of the formation names in this log, we can use this formation tops and formation depths. But for now, maybe we can skip this. Okay, so we just do our here. Okay, so DF, we have already have the DF column depth and column list, and then we are adding new column semi-log, so maybe column stuffs, Okay. So all of these stuffs, the column semilog and column max, column semilog, min def, max def, column min, column max, and colors. So if we run this code, it will change the appearance. Okay. So it looks better right now. Okay, maybe we have to wait for certain seconds to connect again to the internet connection. Okay. There's quite a lag. Destiny, can you hear me?
Yeah, I can hear you.
Okay, I think it's quite weird because I don't see. Okay, so I've just been disconnected. So it's weird because one of my device is connected, but the another device is not connected. Okay, so I will. Okay, I will share my screen right now. Okay, Destiny, is there any question already for this part?
There's none. I think it has been answered already.
Okay, okay, thing here, the logs, right? Okay, okay, so it has been already colored here. Maybe we can adjust a little more for NPHI for 0.3, RHOB from only 2.2 sorry, it's 2.2, 2.25. Which one again for RT? Okay, maybe DT. DT is quite to the left here for from 75 to 100. DTS from 100 to, so until it looks better. Okay, so I think I'm okay. Already disconnected twice. Okay, I will share again my screen. Oh, wow, the DT. Okay, so maybe I can restrict that to 70 from 75, I think from 50 to 90, I think so, for to 90. Okay, so you can adjust your own skills. So here we have already seen this looks better. You can modify the other variable from to 100. Okay, so it's up to you. You want to adjust the scales, and maybe you want to change the colors. You can do so, and maybe yeah, the column semilog. And the important thing is this code. So this column semilog corresponds to what columns are the resistivity, because this is the resistivity is. So if you compare this the previous log and right now, okay, so you will see the difference that right now the scale has been already in a semi-log plot, logarithmic plot. Okay. Okay, so we are right now continuing to producing triple combo because it's quite popular to visualize.
Johannes.
Yeah, sure, Destiny.
Yeah. Someone asks, how can we reverse the DT scale to have 140 to the left and 40 to the right? And then another person asks if it's possible to color the logs by depth.
Oh, sure. Okay. Okay. So for the first question, it's quite easy. You can. So before I showed you on how to adjust the scale for DT for DTS, you can for example DTS here. I want to show from 100 to 175. You only change this numbers to adjust your scale so it looks better. So um, you should define it manually. You have to look many times. For example, this you can adjust this from one, two, three, four. So this one from 1 and to 100K, 1, 2, 3, 4, 100. So it will change the axis as you change the numbers. For the second question, it's a really, really interesting idea. We can feel this log with a depth. But for this time being, for this function, we still cannot do so. But I have already implemented a program that can fill. So for example, this DT, it will fills the color, okay, so that it corresponds to to the DT or the DTS or the program that can do so. But yeah, we can use that kind of plots, and it will surely looks better for a visualization. But after this, I will touch the exactly that you said. We will fill this log. So after this, we are using triple combo. We want to produce the triple combo of this log. As you have been already know, that triple combo is a representation of the well log, array resistivity, and the third column is the rho B and the MPHI stacked together. But but RHOB and the MPHI have an inverted axis. Maybe I can show you again my slide here. Okay, so my slide. Okay, so here you see the triple combo. This is for anyone that hasn't been familiar with what is triple combo and what is neutron density plot. Well, triple combo is a representation that from this plot we can identify is there any hydrocarbon in our formation. So if you see the crossover between this one is actually the bulk density. Bulk density is rho B, the two logs, but so bulk density and neutron the neutron and the bulk density. Uh, if you see the gamma ray reduces, the low gamma ray, high resistivity, and low bulk density and low NPHI, you may identify that the reservoir has some hydrocarbons. And it happens in the Hugin formation that we are seeing in this tutorial. So Hugin formation, as we will see, in our code, it will show us exactly the crossover in the Huygens formation, and we can see that this formation has a considerable amount of use another function. The triple. Okay, so again
Sorry, Your
we
Highness.
yeah.
Um,
Okay.
someone is still asking for that FM tops, FM dot tops. If you could still explain it, you didn't explain it last time. That's fine. Are you with us? Johannes, are you
Sure.
there?
Okay. Okay. So in this tutorial, we have. Yeah. I hear you.
Okay,
You hear me,
good.
Destiny?
Yes, I can hear you. Good, good, good.
Okay. Okay. So yeah. This training we have two data. The first data is the well log, and the second one is the formation tops. When we are producing the data, okay, originally the well-log data doesn't have the formation labels or formation names, okay? So you see here, there is no formation label. Why I need a formation label? Because in certain workflow, information evaluation, we wish to differentiate the properties of each formation. So if we can visualize our data with respect to formation names, it will be better, okay? So that's why in this workflow, I want um, to produce names. And this one is the formation name. You have 9 formations from Hordaland to Sleipner. The Huygens is our reservoir. And I want to bring this information to our data. Okay. So in the end, after we are using label generator function, okay, we are right now producing another new label exactly that we want it to be. I have produced the formation label column in our data. The first data, we didn't have formation names, but now we have the formation names. And then if you see here, non-numerical values are that has no data. Why? Because you see this defs 188. If you refer to this file, okay, it is not identified in this information because the first formation starts from 2600 Hordaland group, but data, it starts from 188 meter. So it corresponds to no formation label. And right now, and after the flow, it will not accept any non-numerical values or I can change this unidentified formations into a certain string that is called unknown, or you may, for example, use your own names, for example, Ellie formation or Bobby formation, whatever, but it must be there that your labels have certain names. So I changed this into unknown. So that's why in this workflow, I start with this stuff to go to a thing because when we are right now we are going to triple combo, okay? So in triple combo, um, we will see this impact on our subsequent workflow, which is the neutron density plot. We will continue to our discussion to triple combo. We can do exactly to see all of the details. We can use help and triple combo, and you can see all of the inputs that is required. And as I have told before that this one, okay, this one that I block here are the obligatory or the must have inputs. It means that we have to always use this input. If we just miss one of these inputs, our program, another variables here, the long one here, are the optional variables. So it means that if you just miss this one variable, it still works. Why I include this optional variables, because in the case that for example, before I want to make my visualization looks better, I can add some more properties, for example, colors. Okay, so by default, all the plots will still work even if we don't define this optional variables here, that is using equals. Okay, so right now I want to produce to this one, because this is corresponds to the Hugin formation, which use a considerable amount of hydrocarbon, I guess. And so again, we just copy and paste this inputs, the obligatory, not the optionals. Okay. Okay, so it's easy. We can copy and paste here, and then we define these variables as we did before. Okay, column and all the variables. Okay. Okay, so okay. So this one is the depth, the data frame. Okay, so maybe you still remember, and I hope that you still follow me. We are talking about data frame, and our data frame is this one. This one is our data frame. This one is our data. All of the data that we have here is named well data. Okay, so we define the F as the well. Okay, the column. Okay, the column depth are the name of the depth. Okay, so okay, I think I just delayed it. Okay, let me show you. Okay, the well, I just type all information here. Okay, so if you see here, this one is the depth. So you define here as depth the name of the column, and the gamma ray you just see here. So you have to take a look once more. Okay, with the names. If your gamma ray has a certain name, for example, G.ray. Okay, uh, you cannot type this. You have to type all of this information as exactly as you see in your data frame. So for example, you don't G.ray, okay? So it must be similar to your data frame. So in this case, we have GR, and column resistivity, you have RT here, okay? It's quite hidden somewhere here. RT, okay, R2 resistivity. And this one is the NPHI, okay, the Roby. We just quickly go. And then the minimum depth are the depth range that we want to produce, like 1000 and 700. Okay, just as we did before, we pass all these inputs. Okay, so I think it is quite easy to copy and paste because it's pretty fast to do like this. And naturally, you have to type one by one inputs. That so you have to understand what is the input. Like when you are working with NumPy or SciPy or Pandas, you have to exactly understand what inputs are required for your function. Okay, so here I have typed all of the inputs, and I hope that it will print us the result. Okay, so it's still run here. Okay, so this is the triple combo log here. Okay, what do you see here? Okay, what do you see here? It's really interesting because as I have already explained before, like this one is a gamma ray, this one is a resistivity, and this one the ρB and the NPHI. And the way we define the triple combo, we invert the density and the NPHI so we can see the crossover here. Okay, so we see here the gamma ray for this formation. This is the Hugin formation. Okay, in Hugin formation, we can see here low gamma ray, okay, and an increase in resistivity, okay, very rapid increase here, and you can see exactly the crossover. Okay, in theory, we have already condition, we can spot, this is the hydrocarbon. But sometimes if we are, it can, it may be wrong because if we don't have any core or any, for example, any evidence in the formation that is the formation is hydrocarbon producer, we cannot exactly conclude that this formation is hydrocarbon bearing reservoir. But if you see the report, you can go to the website to access the data set of the full field by Equinor. It's a quite open data set. You can play with the data, production data, well-log data, all the data. If you open the report, it states that this Hugin formation has a hydrocarbon. So we can conclude that this formation a crossover. Okay, and after this, for me maybe or for you I want to adjust the scale from 0 to 125, and resistivity I want to restrict only from 0 0.01. So again, we can add our optional variables. Okay, we have already have these variables, the obligatory variables, the must-have ones, and still there are also other variables. But right now, I don't want to copy paste this inputs. I just want to sort which inputs are important. Okay, so this input, the min gr, is the minimum value. Okay, so I want to use this maximum gamma ray. Okay, the minimum resistivity, I want to adjust the scale from 0.01 and this one. Okay, and also this one is the color. Okay, so for example, I want to change this gamma ray to purple or resistivity to red. You can define with these inputs. Okay, and another thing in the triple combo, we can define the gamma ray line. So a gamma ray line is a line that that describes the separation between sand and or shale. For example, I want, for example, sand is below 50 and shell is above 50. So I want to declare the sand gamma ray line as 50. But here the sand gamma ray line is about like 60, right? 60 API. So I want to change my sand gamma ray line to 50. So below 50 we have sand, and above 50 we have not completely shale, but a formation that has lots of amount of shale. So okay, we can add the optional variables the way for example the min gr I want to produce from 0. Okay, I think 0 is already fine. So if you see that one variable is already fine, you don't have to define. Okay, so just define which variable that you want to change. So for example, the maximum gamma ray to 120, the minimum resistivity I want to produce from 0.01 minimum resistivity. Okay, from 0 K max resistivity until I guess this. Okay, I think the
Yes, sir. Good afternoon, sir. Good evening, sir. No problem, sir. No problem, sir. Yes, sir. I know, sir.
okay. So the maximum resistivity, I think it's already fine, and the NPHI, okay, it's already fine also. Okay, so I want to change this color, the gamma ray color to purple. Okay.
Johannes,
Yes,
Johannes,
Destiny.
I
Yeah.
think our time is already up. Maybe we should just round off with 5 minutes in the next 5 minutes.
How if we extend 30 minutes because it's already like it's just want to is
Yeah,
this yeah 30
yeah. I
minutes
think
more, is it okay?
they're going to be using. They're going to be
Because
using this. There's going to be another meeting. So by 5:30. So and we just have till 5:10. So they gave us till 5:10, 10 minutes past 5. So that's what we have. So I don't
can
know.
we
Maybe we.
extend, for example, like 30 minutes? Can we ask the participants like do we want to continue or just stop because the time is already up? I think it's up to the participants. If the participants want to continue, I think I can continue to I think 30 minutes. But if so, I just ask the participants if they want to continue or continue for another
Yeah,
5 minutes. How about the
I think let's
participants?
just
Because
maybe we can I don't know, but I think there is also another training or meeting. So they want to use the Zoom account, so the Zoom room. So I think that's the basic thing. So I don't
okay,
know.
so how okay, Destiny, how many minutes that you want because I can maybe
I
I
think
can I can rush only
I
for neutron density. 10 minutes,
I
15 minutes.
think maybe just 5 minutes, but yeah, if we could just do everything in 5 minutes, it will be fine.
Okay, sure. I think I can rush, but I think for today's training, I won't explain here because it's quite important to calculate the petrophysical variables. So I think this tutorial will be only for the visualizations only. Okay, I think I can think that I can make a pre-recorded video for that.
Yeah,
But
that
one thing, yeah,
right.
sure, okay.
Yeah.
Yeah, so I can, so if, okay, so if we just continue here, okay, so you may continue the all of the variables here, okay, it will print us the results that we prefer here, okay. So after this, we are continuing to how to visualize neutron density plot because it's quite fun. So I don't want to leave before the neutron density. I think I can finish the neutron density, and the participants can continue their own for calculating the formation, the petrophysical variables. And right now, we are also using another function that is called the Andy plot. Okay, the Andy plot, it will plot us the neutron density is quite easy. Okay, so neutron density, um, we plot all of these inputs. Okay, these are the obligatory. So we plot the NPHI and the rho b into the plot. Okay, so these are the inputs, the density, the fluid density. Okay, column and column. Okay, okay. So first of all, we specify the fluid density as 1, and the dF again as well. Okay, this one is NPHI, RHOB. Okay, so these variables are important to know. Okay, actually, I want to show you a slide that explain what is column hue and column or color by, but maybe I can walk along from here. I want to plot the NPHI and rho b so that all of the dots that we have has colors. Okay, so I can maybe the column hue. Okay, you will see the result here. Okay, the color by I declare as continuous. You just follow along. Sorry, it's not continuous, but categorical. It's my mistake. Okay, and then Andy plot. Okay, then fluid df column NPHI column rho b column hue and color by. Okay, so you will see here the neutron density plot of the formation of all the formation. Okay, so you will see here each of this dot are corresponds to each formation names. Okay, maybe I want to show these colors not with respect to the formation, but with respect to the gamma ray or any variable. So I can change here. Okay, so you can change to. Okay, so for example, I want to formation label, but the sonic lock. Okay, so I can state this hue, and I have to change this to continuous. Okay, why continuous? Because each of these colors are discrete. Okay, discrete by certain names. Okay, for example, Hordeland, Ecofisk are categorical because they are discrete, but continuous is any value that has like a continuous. So if you want to produce maybe like def is also a continuous variables. Okay, so you can specify it to your own. You may want to produce, for example, anything or maybe gamma ray. Okay, so it's up to you. So you can change it into your own. Okay, so don't forget, if you want to produce this formation label, you have to change it into categorical. Okay, I think it's over right now. We have been already talking until visualization.
Yeah, Johannes, it's really been amazing. It's so unfortunate that we don't have enough time to finish it, but I think you've covered
okay, it's fine.
Covered them at least most of.
Yeah, I think about 70% I have covered before actually there is another workflow to compute, but I think it will be boring to see the numbers. So I think I will stop right now.
Yeah,
the visualizations.
That's
okay.
Really good.
Yeah.
Thank you.
Sure.
Thank you for this amazing session.
Yeah, is there any closing? Yeah. Is there any closing questions from the participants? Maybe I can accept only one or two.
I think there are
before we
none.
are, yeah.
There are no questions. So
Okay.
I think
Okay. That's okay. Yeah. Yeah, Destiny, I think I will make a pre-recorded video to continue the REST workflow. It's
yeah,
quite easy to follow. Okay.
yeah,
So yeah, I
it's
think
better that way.
yeah,
Yeah,
sure. Okay.
so
Yeah.
thank you everyone for viewing, for attending today's class. Don't forget your assignments. By the end of tomorrow, we'll be giving you next week's the next assignments. So endeavor to do it and submit via via your Google Classroom. And we are also going to be sending the pre-recorded videos for the completed PVT app, hopefully by tomorrow. So you could also go through. Go through it. So thank you for attending once again. We hope to see you tomorrow by same time, same link. So thank you very much. Stay put and stay blessed.
Thank you everyone for attending. I'll see you
Thank you, Johannes, for
tomorrow
an
from.
interesting, amazing session.
Thank you, Destiny.
Yeah.
Yeah,
Thank you,
you.
everybody.
Thank you all. I'll see you guys. Soti!